Okay, now it's time for the exercise. You will find it on the last slide of the presentation, of the PowerPoint presentation. As you can see, it consists of 6 tasks. You should have no problem with completing the first 4, and then the last 2 tasks, they require that you should learn a little bit more yourself, Google or try to search in help. So I will go through the tasks very quickly. So first of all, you need to install a special package. It's called read.xl. And the idea is that if you install this package, you will be able to read data directly from Excel files, so you don't have to convert them to CSV files. Then you should learn how to use it and load data from the Excel file people XLS, which is provided. You can find it in Moodle or in handouts. Then you should calculate BMI, its body mass index, and add the calculated values to the original data as a new column. So you can expect that in this people data, there will be height and weight of different people, which you can use to calculate the body mass indices. Then you should create a plot, 2 scatter plots. One is height versus weight, and then one is age versus income. Then this next task is to sort data. So the beer consumption is increasing. It means that the first person has the smallest beer consumption, then the next person has the next beer consumption, and so on. And then show a line series plot for beer versus row number for the sorted data. So let's see how you can solve this, but I recommend you to try to solve it yourself before you watch this video. Spend at least a couple of hours, maybe more, and try to do as many tasks as possible. That's very important for you to learn R better. But I'll start with the first one and install the package read.xl. So I just click install and write the package name read.xl. And write the package name read.xl. Then just click install. Okay. So you can see that RStudio tells me that R should be restarted in order to use this package. It's not a problem. RStudio, you don't need to restart RStudio at least, so just click yes. So now I'm installing the package. And I didn't get any error messages, so it means that the package is installed. And you can find it here, so read.xl, it's this one, okay? If you want to use this package, you either should select it here, and then it will be loaded to your computer memory every time you run RStudio, or you can use a special command, it's called library, I'll show you in a minute. But first we need to find out how to use the package. So I click on this package, and then you can see that it has 2 functions actually, Excel sheets, which gives you a list of all sheets in Excel spreadsheet, and then read.xl, which actually reads XLS files. So let's click on the read.xl. So this is the function. You can see that it has several arguments. The first argument, it's path to the file, or if you have file in the same folder as your script, it's just the file name. Then the sheet number or name, you have the data in, and then you have also some extra arguments like do you need to read column names, do you need to identify column types, and so on. So we will try to play with this a little. Now it's time to get the Excel file, so I just go to the course page in EDX platform. Then if you click Introduction to R and the handouts, it's the very first part of your learning sequence, you can find this file here. You can also find this file in Moodle. So I just click right mouse button, say download linked file as. Then you need to have this file in the same folder where you have all your scripts. So I go to Documents, Code, R, and then Applied Statistics. Okay, save. Yes, now we can get back to RStudio. And if you click Files, you can find this file. You probably need to update it first. So now you can see it here. Okay. So let's look at the file. What do we have in the file actually? You can, if you click on the file name, you will find, you will see 2 options actually: View File or Import Dataset. So you need to click View File, and then you will get Excel with the file content. So what do we have here? We have a typical data set where columns are variables and rows are objects. In this case, we have people. We have 32 persons, 16 males, 16 females, 16 Scandinavians, and 16 Mediterraneans. And then we have some data about the persons. We have height in centimeters, we have weight in kilograms, we have hair length, -1 is short, +1 is long hair, we have shoe size, we have age, we have income, its amount of euro per year. Then we have beer and wine consumption in liters. For example, if you take Lars, and you can see that he drinks 420 liters of beer a year. Then we have sex, it's a gender of person, -1 for male and +1 for female. We have swimming ability, it's a kind of index how good the person is swimming. Then we have region, -1 for Scandinavia, -1 for Scandinavia and +1 for the Mediterranean region. Then finally in IQ. We will use this data eventually in this course for learning different methods. So far we just need to read it. And you can see we have only one actually sheet in this data set. So let's try to use function readExcel for reading the data. So that's the help. Now how to use this function? Well, first I told you already that this function belongs to this library readExcel. If you want to use functions from this library, you either load it here by clicking in this checkbox readExcel, or if you don't need it every day, you can just write library and then readExcel. So you can see RStudio helps you to find it. If you run this, RStudio will load all functions to the memory, so you will be able to use them. But next time you run RStudio, this package will not be loaded. So if you want to use this package only for these particular tasks, that's the best way to do that. So I load the library first, and then I say data equal to readExcel. And then the only thing, actually, the only mandatory arguments, it's a file name, and then I can just write people XLSX. Okay. So let's see if we run this code without any additional arguments, what will we get? So I run this code, and then you can see that we got 32 observations of 13 variables. If we click on this icon, we can see that actually the row names were loaded as a variable as well. So we have row names as a variable, and then we have the other columns. We can solve this small issue by using a workaround. First of all, we need to get all the names to a separate variable. I'll just use names equal to data and then first column. Okay. Then we create a subset of our data by skipping the first column. This is how to do it. You say data equal to data and then comma -1. It means take all columns from your data but not the first one. Then we can just define row names for the data using the variable names. So if you run these 3 lines of code and look at this, at the variable data now, you can see now we have 12 variables and 32 observations. So if you click here, you can see that if you open it, you can see that now we have row names correctly. Okay. So it means that we have solved the first 2 tasks, how to install package and learned how to use it, and how to load data from people XLSX. Now it's time to talk about how to calculate BMI and add the calculated values to the original data as a new column. Okay. Let's assume that you don't know what BMI is. So we go to Google and try to search what BMI is. Okay. So you can see that if you go to this Wikipedia, you can see that BMI stands for Body Mass Index, and it's calculated by taking weight in kilogram divided to height in meters squared. Okay. So we have already weight and height, but the problem is that the height in centimeters, so we have to divide it to 100 to get the height in meters. So the BMI can be calculated as following. First of all, we take the weight, it's data $weight. Then we divide it to data $height, divide it to 100, and then we square it. You see, I use the normal arithmetic symbols for division and for taking a power. And by default, R calculates everything using element by element approach. So it means that, for example, if you take data weight and divide to data height, it will take the first value in weight and divide to the first value in height, and then the second value in weight and the second value in height, which is pretty convenient. Okay. So let's see what we get. Usually the normal BMI is a value between like 18 and 35, so we can use this knowledge to check if we get the correct values. So I'll show it. Now I run these two lines, and then look, I got the values about 20, 18, 19, 17, 25, and so on. So it seems like the calculated values are correct. Okay. Now it's time to add BMI as a new column to the data set. We have several possibilities for that. Well, the first possibility is just to use a function cbind. You remember function cbind combine together several data sets by column. So I can just write data equal to cbind. Let me use end data. It's like a new data, so we can keep the original data set. Cbind data and then BMI. Then if I show data and data, let's see what we get. So we have, this is our end data. So you can see that we have the original variables like height, weight, hair length, and so on. Then the last column of the data is BMI. So this is exactly what we wanted to do. So we solved the first three tasks, and now it's time to show the scatter plots. Well, first of all, we need to show scatter plots simultaneously. So you see we have left and the right plot. It means that we have to use function par to split the plotting layout into one row and two columns. So we have left position and right position. Then we need to make two scatter plots, one for height and weight and one for age and income. Okay. So I start with changing the parameter mfrow using function par, and I say it should be one row and two columns. Then the first plot is weight related to height. I will use this notation, data equal to data. Then the second plot, I'll just copy and paste. It should be income related to age. Okay. If you don't remember how to write the names, you can just look at this, at the variable names here. Okay. So if I run it, now I got this exactly what I wanted. We have height here and weight here, so how weight depends on height, so to speak. Then you also have a interesting plot how income depends on age, and then you can see also some trend pretty similar to the trend we saw in height and weight. We will discuss this trend later, of course. If you want, you can add some additional things. For example, you can change color to blue, but that's of course not necessary. I'll just do it. Okay. You can change the main title and all that kind of things. Okay. So now we are here. So we have solved the first four tasks, and the next is to sort data so the beer consumption is increasing. Okay. First of all, you need to learn how to sort data. The idea is following. So far you have this beer values like this. You can see that this is the largest probable value. Then you have 350, sometimes 250. So they are not sorted so far. Okay. We would like to get the beer values and sort them. Well, let's look at the help and try to find something related to sort. Okay. So luckily we got the function sort, which actually does what we need, sorting or ordering vectors. And you see it's very simple. So either you specify the vector, original vector, and it returns the sorted values. And then you can also change is it decreasing sorting or increasing sorting. By default it's increasing. So we need to get the values beer equal to data $beer. And then you need to sort them. Beer is, so I reuse the same variable instead of producing a new one. Sort beer, and then I show the sorted values just to check if indeed we get them sorted. So you can see indeed we have the smallest and the next smallest and the next smallest. So we got the sorted beer values. Now we just need to show these values as a plot, as a series plot, as a line series plot. So just write plot beer, and I will use type B for this plot, and also change the color to blue. So you see the sorted values, but what I forgot to change the layout. I still have this layout with two plots. So let me change it first. mfrow equal to c11. I change it to default layout and then run the code. So you can see that actually if you start, if you look at this plot, you can see that you don't have any groups here, right? So the beer consumption is distributed evenly. Some people drink a little bit more, some people drink a little bit less, but you don't have any clear groups like those who don't drink beer at all and those who drink it a lot. Okay. So now the exercise is done. So we have solved all the 5 tasks, and I hope you are able to do it yourself as well.